Every 14 minutes and 31 seconds, another piece of the Pacific Ring of Fire fractures. I want you to sit with that number for a moment. Every 14 minutes, while you're watching this video, while you're listening to my voice, the Earth is tearing itself apart in the Philippines and sending shock waves across an entire ocean. What we're witnessing isn't a regional earthquake problem anymore. It's a planetary scale mechanical failure. And the implications are so profound that they're forcing us to completely rethink how we understand natural disasters. Let me start by painting you a picture of what's happening beneath the Philippines right now, because this isn't just another earthquake swarm. This is something that defies every geological model we've built over the past century. The Philippines doesn't just sit on fault lines. It is the fault line. Imagine standing at the center of a cosmic collision. 4 massive tectonic plates converge beneath that island nation in the most complex collision zone on Earth. The Philippine Sea Plate diving eastward, the Pacific Plate shoving west, the Eurasian Plate pressing south, the Sunda Plate pushing north. This creates what I call a geological pressure cooker, a place where stress has nowhere else to go but out. For centuries, this unique configuration has made the Philippines one of the most seismically active regions on the planet. Normally, we would see about 100 measurable earthquakes yearly, with roughly 20 causing damage. It was a rhythm. Predictable. Earthquakes every few days, releasing tension gradually in isolated events with regional impacts and local tsunami threats. But 2025 has shattered that pattern completely. What we're witnessing now is unprecedented in the modern seismic record. Since January, microquake activity has more than doubled from previous years. In September alone, we saw the devastating magnitude 6.9 Cebu earthquake that killed at least 79 people. Just 10 days later in October, a magnitude 7.4 quake struck Mindanao, followed by a magnitude 6.9 aftershock within hours. A rare doublet earthquake, 89 deaths, over 1,000 injured. But here's what's truly alarming. These aren't isolated incidents. Advanced monitoring systems are detecting something never before documented in seismic history. Each earthquake isn't just a singular event. It's loading stress onto neighboring fault systems in a synchronized pattern. For the first time, we're seeing seismic evidence of a mechanical connection spanning across the entire Western Pacific. What scientists call cumulative stress transfer on an international scale, and it's happening faster than our warning systems can react. Most people think earthquakes are isolated events, energy release, job done, tectonic plates slip, the energy dissipates, and that's the end of it. But that's not how our planet works. What we call cumulative stress transfer is a process by which seismic energy from one earthquake literally pushes on distant fault lines, fundamentally changing their stability. And here's the critical part. It happens fast. Stress waves travel through Earth's crust at 8 kilometers per second. This isn't theoretical speculation. We've documented it before. The 1,992 Landers earthquake in California triggered quakes across multiple U.S. states. The 2012 Indian Ocean magnitude 8.6 created cascading elastic perturbations affecting Japan. The 2004 Sumatra tsunami affected fault systems across the Pacific. But what's happening now in the Philippines is different. It's bigger, it's faster, and it's synchronized across international boundaries in ways that have never been recorded. Modern seismic analysis reveals that the Philippines sits at the center of what scientists are now calling a mechanical network spanning the Pacific. Think about that. Not just the Philippines, not just Southeast Asia, the entire Pacific. 7 major fault systems are responding to Philippine earthquake activity in real time. The Sunda megathrust in Indonesia is showing increased microquake activity. The Manila Trench in the South China Sea is experiencing dangerous stress accumulation. Japan's Nankai Trough is displaying preliminary fracture signals. Taiwan's Philippine Sea plate boundary has elevated seismic background activity. The Banda Sea faults at the Australia-Indonesia border are experiencing stress field changes. Malaysian Peninsula faults show unprecedented activity levels, and the New Guinea subduction zone has synchronized pressure variations with the Philippine events. What's most alarming is the speed of transfer. Previous cumulative stress transfer events took days or weeks to propagate. The 2025 patterns are happening in minutes to hours. This is a terrifying revelation for seismologists like myself. Fault systems we thought were separate and independent are actually connected through stress transfer networks. When the Philippines shakes, the entire Western Pacific responds almost instantaneously. October 2025 marked the first time in recorded history that 7 countries detected simultaneous seafloor pressure changes from a single earthquake swarm. On November the 2nd at 4:23 in the morning, tsunami detection buoys from the Philippines to Japan registered synchronized pressure anomalies, not from tsunami waves, but from coordinated sea floor movement. The monitoring data is unprecedented, absolutely unprecedented. The Philippines has recorded over 847 earthquakes in the past 30 days. Compare that to a normal average of 8 to 12. Think about that contrast. We're seeing something 70 times higher than baseline. Indonesia's Banda Sea is showing a 300% increase in background seismicity. Malaysia has recorded the first ever seismic activity in historically quiet zones. Taiwan's Philippine sea plate boundary is experiencing micro ruptures. Japan's Nankai Trough is showing stress accumulation patterns. Northern Australia is detecting distant pressure signals. Papua New Guinea's seismic timing has synchronized with Philippine earthquakes. When we map this activity, a disturbing pattern emerges that I need to explain carefully because it changes everything about how we think about earthquake hazards. When the Philippines experiences a major earthquake, stress waves propagate through the Earth's crust in a predictable sequence. Within 5 minutes, local tsunami generation begins. Within 5 to 15 minutes, stress reaches Indonesian fault systems. Within 15 to 30 minutes, Malaysian Peninsula faults respond. Within 30 to 60 minutes, Taiwan and southern Japan detect changes. Within 1 to 3 hours, the Australian continental margin responds. Within 3 to 6 hours, full Pacific Ring of Fire stress redistribution occurs. This is Dr. Ross Stein from the USGS talking about what's happening. We're witnessing earthquake clustering on an international scale. The Philippines isn't just triggering local events. It's mechanically connected to fault systems across the entire Western Pacific. The acceleration factor is what's most concerning. What typically took hours in previous events is now happening in minutes. The 2025 swarm isn't just stronger, it's faster. It's creating cascading failures across multiple countries before warning systems can respond. And this brings me to what I find most frightening about this situation. What happens to tsunamis when multiple countries experience earthquakes simultaneously? The traditional tsunami model is simple. One earthquake creates one tsunami wave train. The wave travels outward, reaches a coastline, causes damage, and recedes. But what happens when 7 different source points generate tsunamis within hours of each other? The physics is horrifying. Waves from different earthquakes can combine through constructive interference, what scientists call wave superposition, areas where tsunami heights multiply rather than add. If stress transfer triggers major earthquakes across the Pacific network within hours, we would see a tsunami timeline like nothing in recorded history. Picture this scenario playing out over a single afternoon. The Philippines experiences a magnitude 7.2 earthquake generating 8-meter waves. The Sunda megathrust in Indonesia ruptures, a magnitude 8 plus triggered event creating 15-meter waves. Taiwan's Philippine Sea Plate boundary ruptures with a magnitude 7 earthquake adding 5-meter waves to the mix. Japan's Nankai Trough experiences a magnitude 8 triggered rupture generating 12-meter waves. Malaysia's continental shelf ruptures with a magnitude 6.5 earthquake creating 3-meter waves. Australia and New Guinea experience magnitude 7.5 and 7 earthquakes, generating 6 and 4-meter waves respectively. But here's what computer modeling reveals, and this is where things become truly catastrophic. These waves wouldn't remain separate. They'd create amplification zones where multiple tsunami sources converge. The South China Sea would see waves from the Philippines, Malaysia, and Indonesia converging on each other. The Celebes Sea would experience combined Indonesian and Philippine waves interfering constructively. The Pacific Basin would see Japanese and Philippine waves creating interference patterns that multiply their destructive power. What makes this scenario so dangerous is that current tsunami warning systems are designed for single-source events. They were built by engineers who assumed one earthquake equals one tsunami. When 7 countries generate tsunamis simultaneously, warning networks can't process the complexity fast enough. The technology designed to save lives from tsunamis simply wasn't built for this reality. Our current warning systems have 4 critical limitations that I need to lay out for you because they're not abstract problems anymore. They're active liabilities in a scenario that's becoming increasingly plausible. First, national focus. Each country monitors its own fault systems independently in isolation. Second, single source modeling. Tsunami simulations assume one earthquake source. They're not built to handle multi-source interference patterns. Third, communication delays. International alert systems require minutes to hours to coordinate between countries. Fourth, data processing limitations. The systems literally cannot handle simultaneous multi-country seismic input flowing in all at once. The speed problem is the deadliest factor, and I want to walk you through the timeline of why. Stress waves traveling at 8 kilometers per second outpace all human response systems. When a major earthquake strikes, seismic detection takes 2 to 3 minutes to analyze the earthquake data. Tsunami modeling requires 5 to 10 minutes to calculate wave arrival times. International communication needs 10 to 15 minutes for multi-country alerts to propagate through the system. Public warning systems need 15 to 30 minutes for evacuation orders to actually reach people and for people to begin moving. Do you see the mathematics here? When the Philippines triggers a cascading earthquake sequence, affected countries have negative response time. The tsunamis arrive before the warnings. The waves reach coastlines while officials are still typing the alerts into their computer systems. The 2025 wake-up call is clear, and this is what keeps me awake at night when I think about it. Recent monitoring data shows stress transfer events happening faster than our ability to detect and communicate them. We're fighting 21st century disasters with 20th century warning systems. We're using technology from an era when we didn't know earthquakes could trigger each other across international boundaries. Dr. Pekatsu Goda from the University of Bristol put it perfectly. Cascading earthquake hazards represent a new class of disaster that our current monitoring infrastructure cannot handle. We need to completely rethink tsunami warning for the age of stress transfer. But that's just the monitoring problem. The real crisis is the infrastructure reality. 500 million people live within tsunami evacuation zones across the 7 countries affected by this stress transfer network. 500 million. That's the population of the European Union. That's more people than live in the entire United States. And they're all living in coastlines that are mechanically connected through stress transfer. Current evacuation capacity was designed for single country disasters. No existing protocols exist for simultaneous multinational evacuations. When people across 7 countries all need to evacuate at the same time, the roads will be overwhelmed immediately. The shelters won't have space. The coordination between governments, which barely exists now, will collapse under the pressure of simultaneous crisis. Port closures affect international supply chains instantly, creating secondary economic disasters that cascade through the global economy. Food shipments stop. Energy shipments stop. Manufacturing disrupts across continents. The Philippines earthquake swarm has revealed a terrifying truth that changes everything about how we should think about planetary risk. We live on a mechanically connected planet where disasters in one country automatically trigger disasters in others. The evidence is clear. Stress transfer networks are now scientifically documented across the Pacific Ring of Fire. The 2025 events are happening 10 times faster than any historical precedent. 7 countries are now mechanically linked through stress transfer mechanisms that operate at 8 kilometers per second. Current warning infrastructure cannot handle cascading disasters. Every earthquake in the Philippines now carries the potential to trigger the big one in multiple countries simultaneously. We're not facing 7 separate disasters. We're facing one interconnected catastrophe. The Philippine earthquake swarm continues building pressure across the entire Pacific network right now as I speak these words. Each tremor brings the system closer to synchronized failure. And when it comes, when these fault systems finally rupture and cascade, it will redefine our understanding of what a natural disaster can be. It will redefine what it means to prepare, what it means to respond, and fundamentally, what it means to be vulnerable to Earth's power. When stress transfer makes every earthquake an international event, how do we prepare for disasters that cross borders faster than information? If the Philippines can trigger Japan's big one in minutes, what happens to the concept of national disaster preparedness? And when 500 million people across 7 countries face tsunami threats simultaneously, who gets saved first? Who do we choose? What do we sacrifice? We're entering an era of mechanically connected disasters where a tremor in one country becomes a catastrophe for 7. The Philippines earthquake swarm isn't just a regional threat. It's the preview of planetary-scale disasters that move faster than human response systems were ever designed to handle. This is a moment where science is showing us something profound about our planet's vulnerabilities, and we're not yet prepared to face it.